That's why that page is there. Okay, we're going to start here. You got to do -8 divided by 4. And you subtract the exponents, because that's the exponent law, is when you divide two powers of the same base, you subtract their, so this would be -2 x to the 12. Okay, why is that? I'm multiplying x by itself 18 times. So 1, 2, 3 are gone, 4, 5, 6. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 still up there. So step 1 I'm going to do is 7 times 4. So the way, I'll just go ahead and make this a fraction with a 1 under it. And all those x to the -3 means I have to, so like x to the -1 is the same thing as 1 over x to the first. So here, 7 times 4 is 28 over, and you're going to have to move both of those to the denominator. And now we've got 28 over x to the 5th, because I did x times x times x times x times x. So that's how I got x to the 5th on the bottom. Okay, what I do for this one is 2 to the 1st times x to the -6. So this would be 2 to the 1 times -2. -6 times -2. So now I get 2 to the -2 times x to the 12th. So I make it a fraction. If it's a negative exponent, it's not a negative number, it's a small number. So 2 to the negative 2 is going to move down. And then x to the 16th over 2 times 2. Huh, 12. So x to the 12th over 4. Okay, so now we got 3 times 5, and then we got x to the negative 7 times x to the 4th, and that's all over 1. A negative exponent, it's the reciprocal of the positive power. So x to the negative 7 is 1 over x to the 7th. So we would move it to the denominator. So we got 15 times x times x times x. And see, x to the negative 7 is 1 over x to the 7th. So you're going to put 6 down, you're going to put 7 down here. 1, 2, 3, 4, 5, 6, 7. This shows you why. Okay, x divided by x is 1. 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 We've got x times x times x. So if you want to write that as an exponent, let's say, did I do something wrong? Because that wasn't mathing. One over x to the negative 8 is x to the 8. So the big number stays up there. See, I move those down, move those up. It's always the reciprocal of the positive exponent. X divided by x is 1. X divided by x is 1. That leaves me with x times itself 6 times over 5. Okay, we got the next one. Anytime there's a negative there, anytime there's a negative in there, it's a negative 1. Negative 1 squared times x squared. Because these are both to the first power. Power to the power is multiply. Okay. So this means do negative 1 times negative 1 times 8. Those are the coefficients. When you multiply two powers, you add their exponents. Anything to the 0 power anything to 0 power is 1. 1 times 8 is 8. X to the negative fifth is 1 over x to the fifth. They're equivalent. So you move those to the back. Okay, so got 3 to the 6th times negative 4 times 6. Another way to write 9 is 3 squared. So if you have x to the a over x to the b, it's x to the a minus b. So that's the law we're going to be doing. So I'm going to do 3 to the 6 minus 2, x to the negative 24 minus negative 12. So that'd be plus plus. So it'd be 3 to the 4th. Okay, 3 to the 4th. Okay, 3 times 3 is 9. 3 times 3 is 9. So it'd be 81 over 1 times 1 over x to the 12. That's what x to the negative 12 is. Okay, my next question. Okay, so this is really negative 3 to the 1. So I got negative 3 to the 1 times 3, x to the negative 5 times 3. Okay, that's negative 3 to the 3rd. So negative 3 times negative 3 is 9 times negative 3. Negative 27 would be the big number. And then x to the negative 15. And the way I never mess these up is I put them both over 1. So now I've got negative 27 over 1 times x to the negative 15. We move it to the denominator. So what I usually do is take the big numbers and put them in parentheses out in front and just take their operations out of your mind. You just know it's going to be multiply with those numbers. Again, this is where integer rules would be your best thing. So a lot of kids think, hey, that's negative 36. I move it to the denominator. That's not correct because think about it. Negative 36 is not equal to negative 136. This is really small. I mean, really, really small. So it's not the same. So negative 36 is up to the first. Negative 2 plus 9 is 7. Let's see if I can get one more. Okay, next one. Okay, so that's a negative base. So it's really negative 6 to the first. So now I'm going to do negative 6 to the 1 times 2. Now I got x to the 5 times 2. Okay, This is negative 6 squared, x to the 10th. This means negative 6. It's got a negative base. Negative times negative is 36 x to the 10th. Okay, so that's my next problem. And what I do is like that's 9 to the first, 9 to the 1 times 3, and then x to the negative 5 times 3. And it's because you need 9, we need 3 groups of 9x minus 9 times 9 times 9. This is basically 729 over 1 times 1 over x to the x to the 15th. So I get 729. This is 729. I did it again. So this would be 729 over x to the negative 15th is the same thing as 1 over Me personally, I like to rewrite this one. I like to do 4 squared, and we're doing x to the negative 4 squared. This is another way you could show your work. This one we're doing to the third. Power to a power, you multiply. So I'm going to keep going here. I got 4 to the 4th. 3 minus 3, it's gone, so that's 1. And then you go negative 8. So it'd be 4 to the first, x to the negative 2. So this is 4 over 1 times 1 over x squared. It's a reciprocal of the positive power, so you just basically move it to the denominator. Sorry, I'm writing down the problem. Okay, this is a tough question, so just persevere here. Okay, me, what I do on this one particular, I do power to a power on all of them. And over here I do x, there's a 1 and a 1. This would be x to the negative 5 minus 1. Y to the negative 1 minus 1. So, let's see, that'd be 8 to the negative 2. X to the negative 2. Y to the negative 2 times x to the negative 6. Okay, so all of these are going to be the reciprocal of the positive power. Okay, we have options here. We could put the x's together if we want first. And then y. See, this would be 1 over 8 squared times 1 over x to the 8, because it's negative 2 minus 6, times 1 over y to the 4th, because that'd be y to the negative 4. So how did I get where I'm at? I had 8 to the negative 2, x to the negative 8, y to the negative 4. That's why I moved them all down. So see, if I move them, the numerator, there's still a 1 up there. So if you eliminate everything from the top, 8 times 8 is 64, x to the 8 plus 4, 1 over 64, x to the 12. Okay, I keep the fraction a fraction. Okay, we have to be careful on this one, okay? So, we're doing 2/16 times x to the negative 2 minus negative 12, y to the negative 2 minus 2. So it's kind of like like when we multiply, we put them in a different set of parentheses. Well, same thing here. It's 2/16. Hey, that's 1/8. Now I got x to the -2 minus -12 is 10. Y to the -4. And these are both over 1. So I'm going to rewrite it 1/8 times x over 10 to the first. Y to the -4 over 1 is the same thing as 1 over y to the 4th. And you can see 1 times x to the 10th times 1 is x to the 10th. 8 times 1 is 8. Y to the 4th. Up here. Okay, my next problem. Power to a power. It's a different way I could show my work, or you could do 3 to the 1 times 2. Okay, -6. Okay, -6 times -6 times -6. That'd be 36 times 6. So -2/16. 3 to the 3rd is 27. X to the 6 minus -8. Okay, that's -8. Oh, it's 3 squared. That's a 9. 3 squared. X minus -8 is 6 plus 8. Let's hope this is the last one. Hopefully this is the last one. You get 3 over 2 times x to the negative 7 times 2 to the 5th Okay, so I got 3 halves times 2 to the 5th over 1, x to the negative 7 plus negative 5. Okay, I do the finger technique for 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And I got 96 divided by 2. 2, 4, 6, 8, 48. Yes, this is it. The final countdown. I got to write it with a positive power. So when I move it to the denominator, it makes it positive. And we're done.